to the next layer. I'm going to add the next layer to the onion on this topic. So 5x minus 8 over something that's already factored, x plus 3 times x minus 1. And this is getting into the real essence of why this is kind of tricky. Okay, but I'm trying to grade it so it's give you a graded level of difficulty. I'm already 7 minutes in, but yeah, so look at the denominators here, folks, after you take a second to copy it down. Are they the same?
No.
They're not the same. So this one over here has an x minus 1. This one has an x plus 3 and an x minus 1. So how do we get this one to be the same as this one? Well, which one is it missing? Which factor is this one missing? This fraction here in the denominator. Anybody want to give that a try? Take a guess. You see an x minus 1 here and here, but this one does not have a what? An x plus 3. So what you need is an x plus 3 over here. So what I'm going to do, see, this is just like the first problem. Because we had an 8, which is a 4 times 2, and over here we just had a 4. So what we were missing over here in this one was the times 2. So it's very similar over here. What we're missing is a times x plus 3. So what we need to do is just simply extend this fraction, bar, a little bit, and then multiply the bottom by x plus 3. Now our denominator is the same. We got that factor in there. But if we did that on bottom, we have to what? Yeah, so do that on top. All right. Good. Okay, so now all we have to do is simplify. So I'm going to rewrite this thing with just one denominator. And that's x plus 3 times x minus 1. And what I'll do is I'll distribute my 4 and combine it with my 5x minus 8, and then I'm done. So here I go. Copy the 5x minus 8 over here from the first fraction. And then I'm going to distribute 4. So that'll be 4x plus 12. I'll just write it in black. 4x plus 12. And up here, we're just going to have to combine like terms. So 5x and 4x combine to what? 9x, and then negative 8 plus 12. Different signs. Subtract. 12 minus 8. 9x plus 4 over our x plus 3 times x minus 1. And does the top factor? 9x plus 4. Can we factor out a common factor between 9 and 4? No. No. So we can't factor the top. We can't factor the bottom. It's already factored. So we're done. But right there is this idea that I just brought in of multiplying top and bottom by that missing factor. The second fraction was missing the x plus 3 factor. So we had to multiply it on bottom and top. And that is the tough thing about this. If you can get that, then that would be really great. Okay, so let me just move on to our last example for the video, and then I'll do some whiteboard practice with you guys. Okay, this is our last one, adding our final layer. Okay, so it's kind of incorporating a little bit of everything. So bear with me on this. You guys are doing a really good job. Okay, so this is example what, 5? Okay. So you got 2 over 4r times r plus 1 minus a 2 over a 2r. And this is not focused here. Why isn't it focusing? There we go. This is more like what you're going to see in your classwork. Okay. Well, all right. Denominators are clearly the same or not? Not. So we need to look and see what factors are missing from, say, this one, so that we can get it to look exactly like this one. They all need to be the same. in order to do the subtraction we have here. So what am I going to do? Well, if this is a 2r, what do we multiply 2r by to get 4r? 2. So I'm going to want to get a 4r on this side. So we're going to, on this fraction. So I'm going to multiply that bottom by 2. So I can have 4r, just like the first fraction. So now I got my 4r. I'm going to extend the fraction bar. But I got to do that on top as well. Can't forget. And what else is missing from the first fraction that I need over here? We need the r plus 1. So put that on there too. Multiply that too on top and bottom. All right. So right now, we got the same denominator, 4r times r plus 1, except this numerator here changed, and we're going to have to pay attention though. Why is that? Because we actually have a negative to distribute here. So we have that negative 4 there. Negative 2 times 2, that's negative 4, and so we'll have to distribute the negative because this right here, you can't forget that needs to get distributed. So we'll go minus 4 times our r plus 1, and then what that's going to do is give us the right answer, but we need to make sure to distribute the negative 4 over that same 4r times r plus 1. So distribute the negative 4. That equals 2 minus 4r minus 4 as we distribute. Okay, so that's what the top of that thing looks like. The bottom is still the same, 4r times r plus 1. And then we just combine like terms. How do we do that? 2 plus negative 4, that's negative 2, right? And so I'm just going to go negative 4r minus 2 over 4r times r plus 1. Okay, the only thing about this is, this is the correct quantity for the answer, except it can be simplified. So I'm going to say simplify, and this is when we're going to have to recall what we learned from last week, and this is where it gets a little tricky, all right, if it hasn't already for you. Again, hardest topic we're going to learn all year. After this, it gets much easier with square roots and stuff. So what can we factor out from the top? We got a 4 and a 2. What's common? 2. So I'm going to actually pull out a negative 2 because they're both negative. I like taking the negatives out. Having a positive outlook on life. As I'm recording, really? Okay. 2r plus 1. And we have 4r times r plus 1 there. This is Donahue. Don't have him yet. Okay, thanks. No, not yet. He's 6th. Okay, it's okay. All right, bye-bye. All right, so then what do? We got a 2 and a 4. How do those cancel? Divide both by what? 2, yeah, 2, okay. So you divide that by 2, that becomes a 1. Divide that by 2, that becomes a 2. We were really close pretty much the whole time, but you're basically just going to have a negative times a 2r plus 1 over a 2r times r plus 1. And I know that was kind of like, but we've done this before. We've done the whole simplifying thing before, factoring out a common factor and canceling like that. We did it last week. But yeah, that is our final answer. We want to simplify wherever we can. But if you didn't get from here to here, I'm not gonna take off like a half a point even. I'd probably take off like a quarter, because this is the hard work up here, is just getting to here. So that is adding and subtracting rational expressions.